Hello everyone. Today we're going to go ahead and learn how to graph radians in standard position. Okay, so I'm going to go ahead and leave you here with this quick this warm up, and it's going to go ahead and ask you guys um, what is 1 full revolution in radians. So using terms in pi, right? So go ahead and pause the video and give this a try. So what is a full revolution in radians? So if we're talking about a full revolution, we know that that's 360 degrees, but it's also noted as 2 pi. Okay, so given that, we're going to go ahead and work with radians only. I want you to think about how much would half a revolution be. So let's go ahead and draw that. And we're going to go ahead and see that this right here is just going to be half of 2 pi. So if a full revolution, like we saw in the first question, was 2 pi, then this must be just pi, right? Which is makes sense because that's 180 degrees. So how about 1/4 of a revolution? So let's go ahead and see that right now. 1/4 like this. Well, it's gonna actually be half of the half, right? So it should be pi over 2, which is our 90 degrees. And that makes sense. We can go ahead and see that how it was a full revolution, then it just became the top side, right? And then just a quarter of 360. Okay, so let's go ahead and see what we have going on. Well, this right here is looking ahead at what's going to happen this week. Keep in mind that tomorrow our 4.2 is due, and today our 4.3 will be due on Friday, sorry. Okay, so the goal here today is to sketch in standard position. One thing that I do want you to know is that you must know your quadrants. So keep in mind, we probably learned this in geometry in Algebra 1 or Algebra 2, but a lot of us tend to forget these, but hopefully you can go ahead and write them down and you remember them pretty quickly. Okay, so let's go ahead and do this first example. So go ahead and pause the video and give these questions a try. Okay, so 120 degrees, if we remember our numbers right here, this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270. If we do a full circle, that is 360 degrees. So hopefully you're able to see that our 120 degrees will be in quadrant 2, right? Because it's bigger than 90 and it's less than 180. So this right here should be our angle that we are working with. From here to here is 120 degrees. Okay, for question number 2, we have negative 30 degrees. Negative 30 degrees. Keep in mind that if you're going negative, you're going in this direction. And this would be 0. This would be negative 90. This would be negative 180. I'm going to go ahead and sub right here, negative 270, because I want you to see that negative 30 exists in quadrant 4. And it's from here, from the x-axis, if you will, from the standard position to something around that right here. This is our negative 30 degrees. Okay, how about 410? Well, keep in mind 410 is bigger than 360, right? So 410 is bigger than 360. And we can go ahead and see that that is 50. So it's going to go ahead and do 1 full revolution, right? Because 1 full revolution gave us 360 and a little bit more. How much more? Well, 50 more, right? So this right here is our solution. So hopefully it's not that bad. And we can see that this right here would be our angle. And it went 1 full circle, right? Just like a little swivel, if you will. Okay. So what I want you to know is this is what's going to go ahead and happen. This is leading to our goal of learning about the unit circle. And we have these very, very common angles. So pi over 6, which by now you should know that is 30 degrees. Pi over 4, which by now is 45. Pi over 3, we know how to convert, so we know that is 60. And pi over 2, that is 90. Okay, so by now we know all of this good stuff. So you're probably wondering, well, cool, what do I need it for? Well, that's a good question. Well, keep in mind that not oftentimes will be very pretty angles like this. Sometimes they might be multiples of these given angles. So let's go ahead and break this down. So let's say I have just pi. And hopefully you're able to see that if I just have pi, it's just the top side of this circle, this unit circle. Okay, let's go ahead and get a little bit more complex. And we have pi over 2. Well, if I have pi over 2, I'm going to go ahead and see the top side of my unit circle, which I'll write in blue. But now I'm going to go ahead and split this into 2 equal parts. And hopefully you're able to see that if I split 180, right, our pi is 180, the top side of the circle, I'm going to split it equally, and each side should be the 90. So this one, it pretty much does it for us automatically, this little y-axis. Went ahead and did that for us. Here's one section of pi over 2, whoops, and here's the other section, pi over 2. Ideally, 2 pi over 2 is the same thing as pi. Okay, if we do reduce it, right? The next one, let's go ahead and look at pi over 3. This right here tends to be my student's favorite because of how it looks like the peace sign, because you go ahead and split this right here. So let me go ahead and just draw a circle just to see if that makes it a little bit easier. And if I draw the top side of my circle, and I'm going to go ahead and split this into 3 equal parts, where each part is going to be of 60 degrees, or pi over 3. So you're probably wondering, well, where's the third part? Well, keep in mind, it'll be right here on the value. This is 3 pi over 3. This should have been 2 pi over 3. Each little slice is going to be a pi over 3, pi over 3, and 3 pi over 3, you know? So we go from one little section to a second to a third. Okay, let's go ahead and try it with pi over 4. I'm going to go ahead and look at the top side of my circle, which is just pi, 180. And I'm going to split this into sections, equal sections, 4 equal sections, right? So it's going to be 1 slice, 2 slices, 3 slices, and 4 slices, where each slice is pi over 4. Okay, so pretty much this right here is what you are dividing. The top side is what you're dividing into this right here. The denominator will tell you how many equal slices you will need. Okay, last but not least, pi over 6. I'm going to go ahead and see that. This right here. This one's going to be a little tougher, especially because I wrote it really tiny. I'm going to do that again. Yeah, this should be better. Okay, so we have something like this, and we're going to split this up into 6 equal sections. So this one's a little bit more tougher. We just know that in each quadrant, you can go ahead and draw a slice. Yeah, you can draw 3 slices in each quadrant. So right here in quadrant number 1, I went ahead and did 3. And in quadrant number 2, I can do another 3. And the last one is always on the side of pi, meaning this little right here. Okay. Now, hopefully you're thinking about two other questions. You're probably wondering, hey, Ms. Christina, what happens if this was like pi over, let's say, a crazy number of, I don't know, crazy number 12? That's a good question. Well, now you're doing the same thing, but you're dividing these into sections of 12, meaning 15 degrees. Meaning you're going to go ahead and have 1, 2, 3, 4, 5, 7, 8, 9, 10. Oops, I missed 11 and 12. Oops, sorry. Well, ideally you have 12 different slices right here on the top. Okay. The second question you should be thinking about is like, hey, what if it was like 3 pi over 2? What happens then? Well, you do the same thing. You divide your circle into sections of 2, so easy peasy right here. Each quadrant has 1, and we want 3 of them. So I have 1 right here. Here's 2. Dilemma, I don't have another one. Well, keep in mind, guys, there is also another pi in the bottom, because ideally a full circle is 2 pi. So we were just working with the first pi, but keep in mind, if you need more slices, they exist. And the same thing goes with the wheel, you know, the circle keeps spinning, so you can do as many more rotations as you need to. Okay, so ideally you just extend these lines. This is my third. So this is pretty much what I want you to know. From here, all the way over here would be our graph. Okay. So let's go ahead and practice these. 2 pi over 3. So let's go ahead and give this a try. And we have the following. Sorry. So let's break this down. I want 2 pi, right? I want 2 pi, and I want to split this into sections of 3, right? Meaning my top side, which is 0, this is pi, and this is 2 pi. I'm going to go ahead and split the top side into sections of 3. So keep in mind, this is what my students call the peace sign. So yeah, this right here, pi over 3 is one of them right here, which you guys should know by 60 degrees. And then another one, if I do it equally, I should see that this right here is another pi over 3. So pi over 3 plus pi over 3 gives me 2 pi over 3. All right, and I add one more, this should give me 3 pi over 3. And if I reduce it, that's the same thing as saying pi, right? Okay. Now, keep in mind, how many of these slices do I want? Well, I want, let's go ahead and agree. I want 2 out of these 3. So remember, here's 1, and here's another one. So I'm going to go ahead and go from the standard position. I'm going to go ahead and go all the way to here, right? And this will go ahead and give me my 2 pi, my 2 pi over 3. Let me do it in pen. This will give you my 2 pi over 3. So just to make sure we got it, it's from here all the way here. Okay, pretty cool, right? Alrighty. And let's go ahead and try this one. So go ahead and pause the video and give this one a try. So we want 3 of them, right? We want 3 pi, but each section, each pi, meaning the top side and the bottom side, gets divided into sections of 4. Sections of 4, right? So this right here, I have the following. It's going to be one section right here. It's going to be 1 section of pi over 4. Another section of pi over 4. So pi over 4 plus pi over 4, right? A quarter plus another quarter gives me 2 pi over 4, which is the same thing as pi over 2, right? Let's go ahead and add one more slice. And we get to see that 2 pi over 4 plus another one, 2 plus another one gives me 3 pi over 4. And if I do, to finish this off, this will land right in this x-axis right here. And that will be another, which is 4 pi over 4, which we know reduces to pi. And that makes sense. We did something right. Okay, so let's go ahead and sketch this. We want to go ahead and start always in the standard position. And I want 3, right, of the 4. So 3 of the 4. So here's 1 slice, right? This is another slice. Oops. And this is another slice. There. So I'm going to go ahead and stop right over here. So from here is our angle, which should be our 3 pi over 4. Now keep in mind, you will be encountering some parts where it continues more than just 180, and that's perfectly fine. You just extend these lines right here, and that won't do you any harm. Okay, any questions so far? Alrighty, 5 pi over 6. So go ahead and pause the video for this question right here. So we have pi over 6, so I want 5 pi. And each section, each pi, remember our pi is right here, and we have another pi at the bottom, is going to get split up into these sections. So let's go ahead and give that a try. So pause the video, give that a try. Okay, so hopefully you're able to get something like this. So pi over 6 means there's going to be 3 sections in each quadrant. So this right here is pi over 3. I'm sorry, pi over 6, sorry. And this right here, I got another one. This right here is pi over 6, which is another one, so it should be 2 pi over 6, right? And if I add another one, I get 3 pi over 6, which is the same thing as saying pi over 2. Keep in mind, I'm just going to go ahead and reflect this. So if I go ahead and do that one more, 3 pi over 6 plus another pi over 6, that is another pi over 6, so that's 4 pi over 6. And if I do one more, this right here is 5 pi over 6. And last but not least, totally not symmetrical. I add another one, this will give me another pi over 6, which is 6 pi over 6, which we know reduces to pi. So keep in mind, guys, we're going to go ahead and want, right? We're going to go ahead and want 5 of these 6 slices. So we always start right here in the x-axis, and we're going to go ahead and go to the 6 of them, right? Because here was 1, here's another one, here's another one, here's another one, and I want 5. So from here all the way over here. Okay, so we can go ahead and see that this right here will be our angle of our 5 pi over 6, right? Awesome. Hopefully it's not that bad. The next ones are going to get a little tougher, but they're not impossible. Okay, so look at this one right here. We have some sort of improper fraction, right? So option 1 would tell us, hey, let's go ahead and see, let's go ahead and reduce it. The next option would be, let's go ahead and split up like we normally will. Both of them will work. I'm going to go ahead and stick to the same method that we've been approaching just to keep it consistent. But if you see that, hey, I can go ahead and see how many full rotations this is, you can go ahead and do that. Okay, so we have that I want 10 pi, right, out of sections of 3. So on the top I have 3, on the bottom I have 3, but that's 6. And then I want another 3 on top, that's 9. So it's probably going to be in quadrant 3, right? And what I'm doing here to think about it is that I know from here to here there's 3 slices. Another here's another 3 slices. And if I continue doing that, I can see that by the time it gets here, it'll be 9 slices. Okay, so let's go ahead and split this up. So pi over 3, that's that little peace sign. And we can see this right here. This is pi over 3. Okay, and I'm going to go ahead and split this up. This right here will go ahead and give me my other pi over 3, which is 2 pi over 3. And last but not least, I got this right here. This will be giving me 3 pi over 3. Okay, which we know reduces to pi. Okay, I am not done here. As you can see, this 10 is bigger than my 3, so I'm going to go ahead and extend these little lines right here and label them accordingly. So this will be 4 pi over 3. Extending this one, I will get my 5 pi over 3. Okay, and then extending this other one right on the x-axis, I get my 6 pi over 3, and we can see that this reduces to 2 pi, so I'm on to a good track. To make this easier, I'm going to go ahead and get a different marker, and I have this one right here. So if I do one more slice, so this right here, right on the same line, I go ahead and see that this will give me 7 pi over 6. And if I keep doing this, I get another pi over 6, which gives me 8 pi over 6. And as we predicted, if I continue doing this, this will go ahead and give me my 9 pi over 6. And one more will land me where we expected. This will go ahead and give me my 10 pi over 6. Okay, so let's go ahead and sketch this out. As you guys can imagine, this went a whole entire circle. So I'm going to go ahead and do it in a different marker because I already used green. So it went from here, right? From the standard position. It went one full rotation. So let's go ahead and draw that. One full rotation. And then it went a pi more and one more slice, right? So this right here is what we should be looking at. So let's go ahead and see. Let me do it in purple. Our angle should be this right here. This right here. Looks super messy, right? Okay, so that should be our angle. Okay, let's go ahead and give another one a try. So negative 4 pi over 3. So this right here, keep in mind it is negative. So instead of going how it normally does in a positive direction, it's going to go ahead and go to the negative direction. So, but the idea is the same. So we're going to split this up into sections of 3. So one slice of negative pi over 3. Notice I started at the bottom now because I'm looking at the negatives, right? So this negative pi over 3. Then another slice, it's negative 2 pi over 3. And if I continue doing this, this is negative 3 pi over 3, which is the same thing as negative pi. And just one more slice will go in and tell me that this is going to be negative 4 pi over 3. Just where we want to land, right? So let's go ahead and see our highlighter. It's going to be from here, right? Standard position. It's going to go ahead and go down because we were doing the negative version of this, right? And it says it right here, the negative version. Okay, so this is our negative 4 pi over 3. Really bad. Okay, what my students like to think about this, especially last year, one of my students let me know that, hey, this reminds me of this logo. So I went ahead and looked it up, and here's what we came up with. So this is a very nice visualization of what we are doing. Keep in mind, we want 5 of them out of these 6 equal slices. So each one of these is pi over 6, 2 pi over 6, 3 pi over 6. And hopefully you're able to see that what we are going after right now. And then this is 5 pi over 6. So we were able to see how this went ahead and worked. So we went from here all the way to right over here as the angle of 5 pi over 6. Okay. Alright, so just to help you guys out on these right here, these are going to be quick examples. So let's go ahead and go through them. Pi over 3. So go ahead and pause the video and give these a try. Pi over 3 should not have messed you up. Let's go ahead and go double speed here. Pi over 3 is right here. Okay, 9 pi over 3. Well, keep in mind, this right here is 4 pi over 4, right? Because that reduces to pi. And 2 pi, if I multiply by 4 over 4, that gives me 8 pi over 4. Okay, so what I want you to know is that we are working in sections of pi over 4, pi over 4. Oh, dang, I can't write down. Here you go. Pi over 4. But in this case, we went ahead and did a full revolution, right? So from here, 1 full revolution, because that would have made us 8 pi over 4, as we just saw. But I want 9, so 1 more slice, so right here. So this should be a circle and a little slice more. Okay, let's go ahead and try the next one. 13 pi over 6. So we're going to do the same idea. This is pi. I'm going to go ahead and multiply it by 6 over 6 because I want to, instead of drawing all my lines, I'm going to go ahead and see that this is 6 pi over 6. Keep in mind, you can draw the 6 little lines if you want to, just that I made these a little smaller. But you can totally do that for this question and the next ones. And then you just have to reflect. And as you can see, this right here will have 6 little sections, and then you'll have 6 sections at the bottom. So and all I have to do is extend these lines to the other side, and we should be golden. I'm just extending these, and this one I'm going to go ahead and extend it right here. So hopefully you can see that this is the top side is 6 pi over 6, and the bottom part gives me my 12 pi over 6. And I want another one, so this will be 13 pi over 6. So if I do it with my handy dandy highlighter, I can go ahead and see that. I'll do it with green. I can go ahead and see that from here it went a full revolution and a little bit more. And I'll do it in, let's see, what color did I not use? Purple. Yeah. So our answer should be this right here. Right here. Keep in mind it did a full revolution, right? Super messy. Okay, last but not least, we have this one right here, and I think I repeated the question here. Okay, so we're gonna go ahead and see that this is pi, right? Negative pi, because this is negative, so it's gonna be going clockwise, right? In negative, and this right here, whoops, see this right here, it's my positive. So this is negative, so I'm gonna go ahead and go in this direction, and I'm gonna be splitting this up into sections of 3. So this does look like my pi sign, so my p sign, negative pi over 3. This is negative 2 pi over 3. This is negative 3 pi over 3. And one more, this will give me negative 4 pi over 3. So you can go ahead and see that this right here would be our solution, right? From here all the way over here would be our solution of negative 4 pi over 3. Okay, for homework, guys, nothing too bad. We want to go ahead and do these little graphs. These are due in your notebooks. Keep in mind, if you're struggling to use your digital notebook, you can always send me it on a paper and pencil picture, and I will go ahead and accept that solutions as well. Okay. Other than that, guys, that's all that I have for you, and hopefully this made a lot more sense. If you do have questions, please leave a question in the comments, or you can go ahead and email me or anything. Okay, alrighty. This is also optimized for Pear Deck, so if there's any teachers watching this, I will gladly send you the PowerPoint. Okay, as always, guys, thank you and goodbye.